Hey everyone, welcome to this session by Intellipaat, where you'll be looking at some of the most commonly asked cloud computing interview questions along with their detailed answers. Cloud computing has been termed the revolution of the 21st century by leading experts in the field, many of whom we have had the opportunity to interview as well. Keep in mind that these tech leaders also play a key role in hiring cloud engineers, which is why after discussing with them and tracking the latest industry trends, we have put together the top 30 most frequently asked interview questions in cloud computing. If you are still skeptical or just starting a career as a cloud engineer, here are some significant facts that will help you guide your decision. According to an article by India Today, cloud computing jobs are growing at a 30% year-on-year. And in India alone, as of August 2024, there are 20,000 plus jobs available in the cloud domain. If this wasn't enough already, you can Google cloud computing jobs in India and you'll find over 53,000 plus cloud computing jobs, and that too just in India. Talking about the salaries, cloud computing is amongst the highest paying tech jobs, with salaries ranging from 5 to 13 lakhs per annum. And a senior cloud engineer having 15 plus of experience earning above 25 lakhs per annum. When such a promising opportunity arises, don't you think it's essential to acquire the right skills? Well, that is where this video comes in. In this session, we have covered a wide range of topics, starting with an introduction to cloud computing and its importance, followed by the different types of cloud computing services as well as the security aspects, data storage, data management, and so much more. So whether you are starting with cloud computing or just brushing up before your next big interview, this video will give you the edge you need to succeed. So without any further delays, let's get started.
So coming to the first question on the top cloud computing interview questions and answer set, we have a question that states compare between cloud and on-premise computing. Well, whenever we go on to compare cloud and on-premise computing, you really have to talk about 5 very important points. And the first thing is, of course, it's always going to be initial cost, because so whenever you're talking about a cloud computing environment, your initial cost to set up the hardware is extremely low compared to having an on-premise setup. And then coming to maintenance is mostly hassle-free in a cloud computing environment, because you really do not have to have experts standing by working with the hardware, associated software, network and all of that. But in the case of on-premise software, you do require good amount of expertise there. And when you're thinking about scalability and upgradability, right? Cloud computing, the middle name of cloud computing should be scalability and upgradability in my name, because it's automatic, it's excellent, it does a very good job of, if you want to go from, if you want to scale from, let's say, 1 gigabyte storage to 10 terabytes in matter of, half an hour, it is really possible that quick today. And it's not only that, right? So when you're talking about upgradability, you want to use the computing power of one machine versus 10, 12, 30 at a moment's notice. Yes, it's possible. And then when you think about, one of the biggest advantages of cloud computing is the pay as you go policy, because at the end of the day, you'll only be putting down money for the things that that cost you money, basically, at the end of the day. So what I mean by that is, if you're using certain computing resources, you'll only be charged for that rather than the the entire thing, for example. So in that particular case, depending on how much storage you use, how much computing power you use, for what amount of time has your cloud computing environment been running, it's been up, the instance has been created and it's being used, based on all of that, you will have to pay as per you go. Now, coming to the second question, it states, what is a cloud? Well, this is a very generic question, so make sure you do not get carried away by the simplicity of the question. Make sure to keep the answer concise. See, a cloud is nothing but a collection of networks, collection of hardware, services, storage, and an interface that brings it all together to make sure that you can provide all of these, right? Hardware, computing power, and storage as a service to the people out there who have access to an internet connections. So who uses cloud? Well, we have end users who make use of cloud. For example, we ourselves will be using a lot of cloud, right? Think about it. Backing up your photos to the Apple iCloud or Google Photos itself is using a cloud service. And then you have business management users and, of course, the cloud providers themselves, right? So the service providers themselves are the ones who are providing the service. There are a lot of big names when it comes to cloud computing, and you can either use it for personal usages or business applications too. Coming to question number 3, it can be a follow-up to the previous question, but here we're asking, what is cloud computing? See, when you're talking about cloud computing, you have to understand that it's not only just cloud storage, it's a lot more than that. It's literally having supercomputers at the tip of your fingers and using all of its computing power, all of its resources, all of its storage as well. So, you can do everything with today's cloud computing out there. You can run, government organizations, military networks. You can, handle everything that's present in space as well with the use of cloud computing networks. Yes, NASA does use a lot of cloud computing. It's a very important innovation in the modern world where technology is provided as a service, and based on the user's requirements, technology can be implemented in a way to cater to very specific requirements without having to put down a lot of money or a lot of time too. This is cloud computing in a whole. Now, coming to question number 4, it says, what are the benefits of cloud computing? Well, again, this is another question which is very, which makes it very easy for you to get carried away with the answer. But I definitely recommend, at least taking your time to answer it in a concise way with at least 4 or 5 points to talk about the benefits of cloud computing. I am sure you can probably state 10 or 15 points. It's really good. If you're not explaining the points, do talk about the points and list them. But if you want to explain about each different point, make sure you're keeping the answer concise. For example, you can have automated data backups, automated storage of data. You can have very powerful server capabilities, very good amount of productivity. There's not much upfront cost for the hardware. You can save a lot of money. You can save a lot of time. You can access it remotely from any part of the world, depending on how good your internet connection is and all of that. So you can go on and on and on. So make sure you're sticking to at least 5 very good foundational points such as this, and then build your way from there. Coming to the 5th question, it says mention the layers of the PaaS or the PaaS architecture. See, whenever we're talking about PaaS, you have to know that it's platform as a service, right? So you get a lot of details in PaaS, SaaS, and of course, the other kinds of architectures that are present in cloud computing as well. But one thing is that whenever you're asked a specific question, such as we want the layers of PaaS architecture, make sure to know that exactly as how I've shown here. See, there's 3 main layers. One is the cloud controller layer. Of course, we have the storage services layer, and we have the application storage layer. Now, when you're talking about the platform as a service architecture here, what we do with the cloud controller is we make sure that, you have virtual machines that get created. You have controllers for those virtual machines. You can deploy the applications. You can connect to services, scale up, scale down based on your requirement and match, the requirements. So all the things that control the actual environment through which you're going to run your machines on, that's cloud controller. And then we have the storage services. Of course, we have to have a place where we can manage data, ingest data, process it, and store it, right? For that particular case, you can make use of objects, we can make use of NoSQL, the relational databases, block storage. There's a lot of different kinds of storage services that are provided. And then, of course, when you're thinking about the applications that get stored in these, right? So you can have applications which are, simple to scale. They can be easy to recover from if there was any sort of failure. Chances of failure in today's world of cloud computing is very lean. But even if there is a chance of failure, you can recover your data very easily in a PaaS architecture through this particular storage services as well. I mean, of course, you can go on to explain more and more in case if the interviewer does expect. But this is a good framework to approach this question and answer it effectively. Coming to question number 6, it says, what are the cloud service models that are out there today? Well, you can be asked a question in a very different way, saying, can you explain the various services that the cloud offers today as well? It's the same question. Now, coming to the answer of this, there are 3 main types of, the cloud service models that we have today. One, we have PaaS, which is platform as a service. We have SaaS, software as a service. And of course, we have IaaS, which is infrastructure as a service. If you are in this video at this point of time, I'm sure you have heard of all of these and you know the differences that exist between them. If you do not, I would definitely suggest you check out the cloud computing video that we have. In fact, we have multiple videos on cloud computing here on the Intellipaat YouTube channel. So make sure to brush up on all of the concepts because, this forms to be a very basic foundational concept that you really have to know in case if you're planning to have a serious career in cloud computing. So coming to question number 7, it states, what are the components of Windows Azure? Well, the Windows Azure platform services offer a lot of things, but there are three most important components, under which, of course, you have a lot of other components, so sub components too. We have the cloud computing environment, we have SQL Azure, we have the application fabric, which will allow for a fabric cloud to be used. And then you can have a lot of sub components as well. See, in the cloud, you can have a lot of subcategories of how the cloud is used, and what the cloud provides, what makes it native, what makes it special, and all of that too. And of course, when you're talking about SQL, that's an ocean of its own, right? But once you're asked for the components, do put it out in a clear way, such as this. And of course, if you are asked to explain, there might be a follow-up question saying, okay, can you talk about Microsoft Azure Cloud? In that particular case, of course, with the follow-up question, you can go on to answer that too. Coming to question number 8, it says, what are the differences occurred in distributed operations? Well, whenever we're talking about distributed operations, FC and Nova come into the picture, right? So in FC, we have the operations that take place as a master-slave, master-slave architecture. But then when we're talking about Nova, the main difference here lies in how, processes are executed parallelly and how its data gets shared across, the network or the channel whenever it is required to. So whenever you're thinking about distributed operations, make sure you talk about how master-slave operations work, and of course how the data gets stored, how processes can run, either if it's based on events or if it's based on triggers or if it's based on a requirement for scaling, and a lot of that too. Coming to question number 9, it says, which agent is equivalent of Nova Compute? Well, Nova Compute has a very good equivalent, and in fact, I would say that the equivalent of Nova Compute is Azure Agent to one point of time, because it's considered to be on par with Nova Compute. But in my honest opinion, I think Azure Agent has a lot of lot under its belt that makes it that gives it the particular edge to move it one step ahead of Nova Compute. So what do you guys think? Have you used Nova Compute? Have you used the Azure Agent? If you do have, head to the comment section and do let us know. And then coming to the 10th question, it says, mention the reliability and availability of cloud computing. Well. Again, this is a very important question. There's a very good chance that you'll be asked this particular question, right? So to attack it really well, do talk about how fault handling is done in the world of cloud computing, right? So when we talk about how two virtual machines are used in a single fault domain, if there is one particular hardware that fails, it means that both of your virtual machines can fail. But what a cloud computing platform like Microsoft Azure does in this particular case is it has the capability to automatically distribute instances of a role, across a lot of fault domains too. But when we go on to talk about how we can use the upgrade domains to make sure our data is available and of course it's reliable, right? In that particular case, whenever think of the scenario where a new software version gets rolled out, right? Version control is something that's very important, and every time that this gets done, we make sure that any sort of service that is attached to it, or any sort of data storage that is using this particular instance of it, that it is completely available for usage. And it is making sure that even though there might be multiple instances that get created and operated based upon that, well, in that particular case too, of course, it will be readily available to scale. The availability of programming power and the availability of how data can be scaled in a reliable way is the talk of the day whenever we talk about how we can go on to use upgrade domains. But when we're talking about a cloud computing platform and availability and the reliability in terms of security, one very important thing in my opinion is to talk about network and the storage availability, right? Because you can have your data to be copied in multiple storage areas in multiple different domains across servers in multiple different continents too. So why do we do this? We do this for one, required redundancy, where if there is a data failure, we can pull all the data back to make sure that we have sufficient backups. And the other reason is that if one of these servers, in case if you have accumulated all your data there, is under a DOS or a denial of service attack, in that particular case, you might not be able to access the content present in that server, and it might not be able to function effectively, right? In that particular case, your client, your business, or whatever it is that you're running on the cloud might come to a halt because the server is not able to provide services for you. To avoid all of that, we do have this kind of redundancy that's built in to today's cloud computing platforms. And then coming to the 11th question, it states, give the best example for open source cloud computing. Well, if open source cloud computing has to be spoken about, I think OpenStack always takes the center stage because it's a very, very good example of what an open source platform should be. It's extremely popular among the startups of today, mid-tier companies. It does provide a lot of functionality because, at the end of the day, you might be thinking, do you really have to put in a lot of money into Amazon Web Services, Azure, or Google Cloud Platform? And if you are a small company or if you're starting up, you might not have the budget to allocate that much too. In that particular case, do think about OpenStack, because OpenStack is one of these platforms that will help you rapidly scale up, at least at the start. And it has, of course, thousands and thousands of developers across the globe pitching in to make OpenStack better than what it is every single day. That particular case, I do believe that OpenStack is in fact one of the best examples of open source cloud platforming we have today. Coming to question number 12, it says, what is AMI? How do we implement it? So AMI is basically short for Amazon Machine Engine. What it means is that it is a copy of your root file system itself. It feeds all the information that is required to launch any sort of instance on the AWS platform. So you implement this kind of a machine image whenever you actually want to go, launch a particular instance. Of course, you can have multiple instances that can be launched from one single machine image with the same configuration as well. Of course, if the configurations now become different, then you'll have to launch multiple instances and you'll have to launch multiple AMIs as well. But if you have a same configuration that you want to scale across multiple instances, do remember this important point that you can use the same Amazon machine image too. So the image on the screen, I hope, is pretty self-explanatory at this point of time. You're going to create an EBS snapshot. It's going to get registered with the AMI, which is the Amazon machine image. And once you launch an instance, you can directly start using the instance. And of course, if you want to copy it to another instance, that can be done directly if there is a similar configuration in the meshi in the second instance that you want to launch too. So how can you implement it, right? So coming to the answer of the second part of this, AMI will include one or more of the snapshots of your EBS volumes. Let's say, in the case of backed AMIs, you will have the instance that gets stored. And of course, you will have a lot of other things as well. Think about the template for the root volume, because you'll have to copy it, right? So what are the contents of the template of a root volume? You'll have the application server, you'll have all the applications that bring with it. And what is the most important thing that you require? Of course, an operating system, right? So all of these will be contained in the EBS volumes. So we can go on to basically say that it launches the permission that we decide, based on what AWS account can use what AMI for what instances. That's a mapping that goes on depending on your account too. Now, one very important thing you have to talk about is that it will also require a block device mapping, because at the end of the day, you'll have to specify what volumes have to be attached to what instances whenever they're launched, right? Be it a copy of the same AMI or be it a completely different AMI, you have to, specify the volumes that you want to use, and of course, either you want it to be copied or you want it to start fresh and all of that too. Now, with this, we can move on to question number 13 that states, why are hybrid clouds so important? There are many types of cloud computing today, and guys, you really have to know the different types of cloud computing environments that we have today. And then when you talk about hybrid cloud environments, right, you do have to talk about how they are so effective at what they do. See, there's something called as cloud bursting, where you can access all the capacity and the specialized software that are available, let's say, in a public cloud and not in a private cloud, right? So whenever you're thinking about examples, think about Dynamo, think about Amazon, think about virtual Amazon and others too. So why do we do this? We can leverage the best of both worlds, right? Now, when you're thinking about vCloud is basically a VMware cloud. It's, of course, a little expensive to use, but it will give you enterprise level quality. And then when the talk is about OpenStack makes sure that, you have a commodity for servers and storage. Of course, it's a little less reliable, but then you can run all the web servers on OpenStack. The database can be built on the vCloud, so you can sort of have this kind of a collaboration between 2 or 3 cloud services and make a hybrid cloud based on your requirement of having it to be either in a private space or in a public space too. So for these reasons, for the effectiveness to bring about both kinds of requirements to use specialized software, maybe in an open source kind of a cloud environment, you do require hybrid clouds. And then with that, we can come to the 14th question that says, list the platforms that are used for large scale cloud computing. Now, there's two main platforms that whenever we talk about extremely large scale cloud computing or even generic large scale computing is Apache Hadoop and the concept of MapReduce. These form to be very vital concepts of big data, and big data actually helps a lot in the field of cloud computing because you do have to think about how you can manage all the data effectively, right? So even though there are extremely big names like AWS, Azure, and all of these, even these guys will make sure that your data is stored in an effective way, in an efficient way. To think about all of these, well, you have amazing tools such as Hadoop, and of course you have MapReduce that will help you with storing large scale data, and working with that data without you having to put much effort into it. Now, with this, we can come to the 15th question that states mention the different types of model that are used for deployment in cloud computing. Well, a lot of deployment models that you have to talk about. As I told you, you have to know all of these guys. You have the private cloud, you have public cloud, you have community cloud, and as we checked out, you have the hybrid cloud. And then, of course, adding an example of how you would use a private cloud, what is a public cloud, why would you require a community cloud, and talking about hybrid cloud is definitely going to add a lot of value to your candidature. So, depending on the interview, read the room, read the interviewer. If he or she is expecting more in detail, then do answer that. If they're expecting a concise answer, then at that point of time you can maybe expect a follow-up questions based on that, right? So you state private, public, community, and hybrid. The interviewer might ask you a little bit more about a community cloud in the next question. So if that's the case, make sure to read the room and then answer the question in a clear and a concise way. And then coming to the 16th question, it says explain security management in terms of cloud computing. Well, security has to be the prime thing whenever the talk is about cloud computing, right? Because here we consider identity management, which will make sure that, whoever is using the applications, whoever you using the cloud platform has an authorization to actually access it. And then with access control permission, we can check who's controlling what, who's using what kind of a services, what instance is being run by whom, who is in fact entering the cloud computing environment as a client or as a user, or as a person, who could be a cloud architect or the cloud admin too. So you can restrict access based on all of these. You can have multiple layers of protection through, of course, authentication methodologies and authorization principles that will make sure that you will only have access to the people who need to have specific access to maybe data or in fact even applications as well. So based on all of these, you have to understand that today's world of cloud computing is extremely tight knit when it comes to security, and you can be rest assured that it is extremely good. Hacking into and breaking the security methodologies of a top cloud computing platform today is absolutely no joke at all. Considering that, I definitely think you should talk about the advantages of today's cloud computing security platforms out there too. And then coming to the 17th question, it states, what are the layers of cloud computing? Well, there are many layers of cloud computing, but the most important talk will be, of course, all of these layers. You'll have the cloud controller, as we discussed previously. You'll have the Walrus. You will have the cluster controller, or it's called as the CC. You'll have the storage controller, in short for SC, and of course, you have the node controller, which stands for NC. So these form to be some of the most important layers that get used in any sort of cloud architecture out there. There has to be a scaffolding through which everyone kind of uses that to scale upon, right? Be it the small brands, be it open source platforms, or be it even the big tier organizations too. These layers will be a common commodity for all of them. Now, coming to question number 18, it says explain the full form and the usage of Eucalyptus in cloud computing. Eucalyptus actually has a full form, in case if you guys did not know. It stands for Elastic Utility Computing Architecture for linking your programs to useful systems. Well, that's a mouthful, right? Let me say that again. It's Elastic Utility Computing Architecture for linking your programs to useful systems. What is it now? Well, it's actually an open source software infrastructure that we use in the field of cloud computing, where we can implement any sort of clustering that we want in a platform online. So it's mostly used in today's world, where you can simplify the entire process of building a private cloud, a public cloud, or even a hybrid cloud too. So it will give you the complete capabilities to make sure that you can have your own data center, and you can use this kind of repurpose the data center into a private cloud, cloud. You can have complete functionality over it, and you can do a lot with the software infrastructure in case if you're willing to use Eucalyptus in your native in-house cloud computing platform too. So it's a big name. It's gaining a lot of popularity in today's world again, and it's being used a lot. So there's a very good chance that you will be asked this question. And then coming to question number 19, it states mention the names of some of the large cloud providers and databases. Well, large cloud providers' names, I'm sure you guys will already know. You have AWS, which is Amazon Web Services from Amazon. You have GCP or Google Cloud Platform from Google. And of course, you have Microsoft Azure, right? These three are the big names. Of course, you have OpenShift from Red Hat as well. You have multiple different cloud providers out there. So if you do know more than the 3 or 4 that I stated, do talk about that. And then coming to databases, the three most popular databases in the cloud computing platform from Google, we have Bigtable. From Amazon, we have the ASD or the Amazon Simple Database, and of course you have the cloud-based SQL. It's also called as the sequential query language too. So in that particular case, you do have these three databases followed with the names of the large cloud providers that you can talk about in detail too. And then coming to question number 20, it states, explain the difference between cloud and traditional data centers. See, a traditional data center has one major difference is that it is extremely expensive to run because you'll have a lot of equipment running, a lot of hardware. You have to work. You'll have to spend a huge budget, in fact, on cooling these systems down and keeping it working effectively. You'll have a lot of electricity bills. Well, you'll have to have a lot of inboard security where you need to have physical security to these servers to make sure that people don't access it directly. And there's going to be a lot of expenditure initially in the case of maintaining, and even in the long term, whenever you're running a data center too, it's definitely going to cost money. But then when we're talking about cloud can be scaled up whenever you have a requirement of scaling up. You really do not have to have a lot of cloud, and then you really do not have to have a lot of physical security. Of course, if you have clients connected to the cloud, you do require a lot of security to that. But at the end of the day, you are not you really shouldn't be extremely concerned about how your data can be misused in a physical way, or let's say you really don't have to worry a lot about cooling these servers down or paying electricity bills. Of course, you will be billed for your usage, but it is definitely going to be a lot less rather than having your own data centers, right? So that is very important. Now, keeping that in mind, let's talk about question number 21. Question number 21 states, what are the uses of APIs in cloud services? Well, what are APIs, right? So APIs are short for application programming interfaces. We use this to make sure that, we remove the entire dependency where we have to write complete programs at every single point of time. This will be like a bridge. This will act like a bridge where we are, enabling communications between one or more applications very easily without having to rewrite both of them to run as a single instance. And then at the end of the day, you are doing all of these to make sure that it's easy for the cloud services to run on multiple systems. And of course, it's accessible for users who are doing the same too. So to keep it fast, to keep it effective, and to reduce the amount of redundancy that you will have to put in to write different programs is definitely something that we get to have full control over whenever we're thinking about application programming interfaces, especially in cloud services. Coming to question number 22. Question number 22 states, mention different data center deployments of cloud computing. Well, you will have two primary data centers that you will have to talk about. One is the containerized data centers, and of course the low density data centers. When you're talking about containerized data centers, right? So these are basically packages that we contain, like think about a set of servers. You'll have a lot of network components. You'll have storage delivered to large warehouses where it will be completely sealed off. It will be cooled and all of that, right? So whenever you require a containerized data centers, 99% of the time it will be catered uniquely to your requirement. It's not like a one solution that solves for all the problems. So that is one of the, I would say one of the advantages of using a containerized data center too. And then when you're thinking about a low density data center, right? So here, and then when we're talking about low density data centers, right? See, even before that, one thing you have to know about containerized data centers is that they will promote heavy density, which will, a lot of servers, a lot of network components, which cause a lot of heat. And it's not only just heat and physical troubles, it's going to be an engineering challenge to keep solving all of these day in and day out, right? So to make sure that, you really have good amount of hardware that you have the capability to handle and cater to, you'll be using a low density data center. Here, as the name suggests, just the equipment is established far apart to make sure that it's pretty cool. It doesn't overheat, it doesn't break down, and of course it's protected from the elements in both of the cases too. And then coming to question number 23. Question number 23 states, list down the three basic functioning clouds in cloud computing. Well, there are three very important functioning clouds that you have to talk about. One's the professional cloud, the second is the personal cloud, and the third one is the performance cloud. Well, guys, let me state this again. If you're at this point of time where you might not know what a professional cloud, a personal cloud, or a performance cloud is, I highly recommend you check out, our videos that we have for cloud computing. We do have a lot of videos that go in depth into the functioning clouds as well. So make sure to head to the search bar after this particular video and do check them out in case if you have to brush up on any of these topics. Now, coming to the 24th question, it says, what are the characteristics of cloud architecture that differ from the traditional architecture? Again, your interview can in fact start with this particular question, so make sure that you are prepared to answer this in a very clear way. So what happens in a cloud environment is that the hardware requirement that there is fulfilled as per your demand, right? So if you require a machine that can probably handle 10 clients, yes, that can be done now. If you require a machine that can handle 10,000 clients, yes, that can be provided too. And then when you have a traditional architecture, right, that makes it very difficult to do that. And when you're thinking about cloud architecture, of course, scaling up resources on demand is always there. You can manage workloads. You can have dynamic workloads in a way where you really don't have to worry or break your head about any point of failure. You can save a lot of time, a lot of efficiency. You can work from anywhere across the world. You can have your servers across multiple components. You guys, the characteristics of how a cloud architecture will differ from a traditional architecture, right? So you can save a lot of money in terms of manpower to maintain and handle these servers if you had anything on site too. Now, with that, we can check out the 25th question that states, what are the building blocks of cloud architecture? The three main building blocks or the scaffoldings of cloud architecture, in my opinion, is of course the reference architecture, the technical architecture, and how one can go on to work with the deployment operation architecture. So again, if you are at this point in time, you really have to know all of these concepts, guys. But then if you do not, again, I would urge you to take a look at the in-depth videos we have on the channel for this. And then coming to question number 26, it says, explain AWS. Well, it's very easy to get carried away with this question, but then keep your answer very concise. AWS is a short form that stands for Amazon Web Services. It is probably one of the world's best cloud computing platform that we have today. It's an IaaS, or an infrastructure as a service platform, and it provides a lot of services, right? It's a plethora, it's an ocean of its own whenever we talk about AWS, because 99.99% of what you can do on a traditional native in-house architecture, you can do it on AWS today. That is how convenient, that is how effective it is. All you would require is probably a laptop or a mobile phone that will help you get connected to these kind of services to make full use of that. So the basic requirement to have extreme amounts of computing power at your fingertips is just an internet connection, and AWS is at the top of their game. There's thousands of companies across the globe that make use of AWS daily, and even when you're talking about the aspects of how AWS is scaling up, when you compare it to Microsoft Azure and when you compare it to Google Cloud Platform, these guys are always punching above their weight. And you can of course talk about a lot of points when it comes to AWS. And then coming to 27th question, this is a very important question. It asks, explain how can you vertically scale on an Amazon instance. Now, vertical scaling is probably one of the very important features of AWS and using cloud virtualization too. So how can you do this? We go on to spin a new large instance where we can actually pause that particular instance, detach whatever volume that we have for it and discard that out. And then what happens when we stop our live instance and detach its root volume, right? So here basically we have to note down the unique device ID that comes with it, and using this particular ID we can attach the same root volume to the new server and scale it up and start it again. So what we basically did is we took an EBS volume from one server, we paused that particular instance, we detached it, we connected to, we made sure to note the unique device ID, and then you can go on to directly attach that same root volume to another server in case if it's a bigger requirement, you're scaling up or you're scaling down, and then restart it. That's really as convenient and as simple as it gets, when you're using when you're using vertical scalability and of course cloud virtualization in Amazon's AWS. Now, with that, we can come to question number 28 that says explain the security usage in the Amazon Web Services model. And one thing you really have to know is that AWS supports security groups. Access can be provided based on the jump box, and you have SSH access, which is open for port number 22. But later, if you want to create a web server group or a database group too, yes, that can be created. You can have multiple ports that can be mapping into that. For example, you can have port number 3306 from the web server group. You can have port 22 from the jump box group, and a lot of other things too. So the addition of any machines to any of these web server groups, right, it can be stored in a database. And whenever this is done, one of the most important things in terms of security is that no one can directly SSH into any of these boxes and directly use them, even though the port might be open. So that is one of the ways on how you can solve for a requirement to make sure that no one SSHs into your particular box and accesses the data too. So in that particular case, AWS is doing a good job in terms of security groups. And then coming to question number 29, it says, what are the reasons that make Amazon so big as they are? You can have questions saying, what are the reasons that make Google big, or what are the reasons that make, Microsoft Azure so big and all of that, right? So based on your usage, based on if you've had experiences with that, you can answer this in a clear way. But, since AWS is the most popular one out there, we're talking about that here. So what happens in AWS is that we have the backup storage systems of EBS volumes. This gets maintained directly. So we can do this by inserting a snapshot facility. You can do it via either an API call, or you can make use of an interface, a beautiful graphical user interface called Elastic Fox 2. You can have the performance of your storage spaces improved by making use of RAID arrays. And of course, you can copy your data across multiple volumes and have your RAID array perform at its best while giving you good protection against failure and, of course, good backup redundancy too. So it's not only just two reasons, it's just that it's extremely popular in a way that people are willing to spend billions of dollars, into AWS. And with that comes a lot of development from Amazon themselves to make sure that they're catering to, basically anyone who requires a cloud platform. So be it you're a person who's doing a recreational project, yes, or an entire multinational corporation who wants to scale their complete business into AWS, yes. So depending on how individually can you cater solutions to the problems out there through cloud computing, I think Amazon is doing a really great job of that, and that makes them the biggest cloud provider today. And then coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Again, if you're at this point in time in this particular video, you would already know the value of certification programs, right? So, you will have top of the line teaching. You will become experts in all of the concepts. You will be taught by, you'll be taught by experts across the globe, of course. A good certification program will give you a lot of industry level use cases, a lot of practical hands-on projects, and a lot of other things too. So basically, you can go from a beginner to an expert with a certification program. But what does this signify to the interviewer? See, if you are inclined towards cloud computing, and if you're coming from a very different background, maybe a digital marketing background, or maybe a commerce background, a finance background, whatever it is, even though you might not have a computer science degree at hand, it shows that you have put in certain time, effort, and of course money to become experts into this, knowing that you want to expand your career in this particular field. It shows your dedication, your passion towards cloud computing, and that you're a strong aspirer to get to from where you were to where you are today in terms of expertise in cloud computing, right? So all in all, it'll just tell the interviewer, and it'll give an impression that you are an effective learner, that you're really willing to put in the efforts to become an expert here. So what adds value whenever you're talking about answering this question? One thing is that you might have one certification, you might have cleared a couple of examinations, or you might have multiple certifications too. In that particular case, make sure to list the certifications that you have. But instead of talking about what the certifications covered, I highly recommend you talk about how you used it rather, right? So a certification program is meant to give you a lot of theoretical and practical knowledge. But why is this done? This is done to make sure you can practically start solving problems on your own. So instead of talking about what all you learned, do talk about how it's been helpful to you, how you have used it, and how you plan to put it to effective use in that organization that you're interviewing for now. Answering it this way will make sure that it will add a lot of weight to your candidates. and it's going to leave a good impression on the interviewer too.